Hello and welcome to another session of Excel Programming for Clinicians with me, Dolotson Callum. In this session, we will look at error handling. Now, if you want your Excel programs to really look and feel professional, you need to have an understanding of error handling and how to respond gracefully when something goes wrong in your program. So in this session, we will look specifically at compilation errors, errors that result from missing resources such as files or directories, mathematics errors such as dividing by zero, for instance. Next, we will take a look at various ways in which you can resume your program execution after an error. We'll look at the resume next and the go to statement. Next, we'll take a look at the error object and the information that it provides to us about our error. Finally, we will write a subroutine complete with professional error handling. Okay, let's start by taking a look at compilation errors. In many ways, these are some of the easiest errors to detect because they happen right in front of your eyes. Excel blows up the minute you try to run your code, so you know something is wrong. Most of the time, compilation errors occur because we've forgotten to do something. Let's take a look at some examples. Say I wanted to write a for loop. Let's declare a variable to use as a counter. And let's write our for loop. Now let's run the code. As you can see, we get a compile error, for without next. Essentially, what we've done is we've forgotten to close our loop with a next I. The way you fix this is to include your next I. So this is an error that's very easy to make. You start your for loop, you write a lot of code, and then you forget to close it with your next I, which is why the way I always write my for loop is to write the for and the next first, and then write the code in between those two. Let's take a look at another example. Say I wanted to write some logic. I want to do something if I is greater than 0. Let's run the code and see what we get. Again, we get another compile error. We have an if block with no end if. Again, this is a similar type of error to writing the for loop without the next I. In this case, we've forgotten to write the end if. Again, my tip to you is to always write your if-then section and your end if before writing the actual code between those two. Let's take a look at yet another example. In this case, I want to write a select case based on I. And I want to do something with all cases where I is equal to 1. Let's run the code and see what we get. And unsurprisingly, we get an error. Select case without end select. And once again, the way to fix that is to always write your end section before you actually write the code that you want for your logic. Another type of error that can occur, and this occurs because we've got option explicit set, is when you forget to declare your variable. So let's use a variable j, and we'll set its value to 1. We could want to use j maybe to do a second loop of some kind. Let's run the code and see what we get. And this time we get a variable not defined error. And this comes about because we've set option explicit. And we set option explicit because we want to make sure that all variables we use are declared before they are used. So those are some examples of the different type of compilation errors that you can get as you write your program. Some of them are easy to avoid by getting into good habits. But at the very least, if you do make these mistakes, Excel blows up when you try to run the program, so you know that you've made an error somewhere. The worst errors to make are the silent ones where perhaps in your calculation you've got something wrong, but the program still executes and runs and you don't know you've got an error. So in many ways, compilation errors are the most straightforward. Next, let's take a look at errors you get if there are missing files or directories. So let's assume there's a file I want to open, and I think it's in a certain location. I'm going to define the directory path and the file name and try to open it. So let's declare a variable called drug prescription file path, and that is declared as a string. So that's going to hold the file path to my file I want to open, and I need another variable for my file name. So I think my file is in this location. I'll copy the path. I'll assign that to my drug prescription file path. Now my full drug prescription file name, including path, would be equal to, I use my directory keyword and I pass in my file path. And I concatenate onto that my file name. So I've set my file path and I am using the directory object to create my full file name. So I use my workbooks object and I call the open method and I pass in my drug prescription file name. Okay, let's run that code and see what we get. And as you can see, we get a runtime error. Sorry, we couldn't find, and in this case, it's a blank before the full stop, meaning that the file name is blank. Is it possible it was moved or renamed or deleted? Note that the file error number is 1004. This is useful when we're trying to work out what the error number is. So as we proceed with our error handling code, we need to write code that can handle the situation so that Excel doesn't blow up like this. Instead, it provides our user with a nice message box to say the file they're looking for couldn't be found. Could they look for it somewhere in a different location? Next, let's take a look at some of the mathematics errors that can occur. Okay, we have a scenario where we have to calculate the volume of a particular drug to administer to our patient. We know the dose that the patient needs, and we know the vial size that the drug arrives in. So let's write some variables and do some calculations. So I need a variable for the volume to administer. I'll declare that as an integer. We need a variable for the required dose. We need a variable for the available concentration. And we need a variable for the vial volume. So let's say for our patient, the required dose was 250 milligrams, and the vial came in 5 ml volumes. And the available concentration is 125 milligrams per ml. So we want to calculate the volume to administer given that the required dose is 250 milligrams and the vial volume is 5 ml and the concentration is 125 milligrams per ml. So let's initialize our variables. vial volume is equal to 5, required dose is equal to 250, and let's try to calculate the volume to administer. So the volume to administer would be the required dose divided by the available concentration multiplied by the vial volume. Okay, so we want to calculate the volume to administer, and we know that if we divide the required dose by the available concentration and multiply by the vial volume, we can work out the volume to administer. Let's run the code and see what we get. And we get an error. Runtime error 11, division by 0. What's happened here? If we click debug, it takes us to the line where the error happened. And what we've tried to do, we haven't initialized the required concentration. It's currently set to 0. We're trying to divide by 0, and as you know, division by 0 leads to an error. So this is a very easy mistake to make as you're initializing your variables. If you forget to initialize one of your key variables, you can very easily run into an error. Next, let's take a look at the resume next function. Now, without resume next, whenever an error occurs, Excel gives an error message and stops executing your code. Now, there may be situations where you actually want Excel to carry on and not just stop abruptly. When you want that to be the case, you use the resume next keyword. Let's see that in action. Let's copy our code from before and paste it into our resume next sub-procedure. Let's say we didn't want Excel to blow up at the line it's doing the calculation, but we want it to give us a message box. So we want our program execution to continue and give us a message box with the required volume to administer. But Excel blows up if it runs into an error. The way to stop that is early on in your code, you say on error, resume next. What this tells Excel to do is that when it runs into an error, you want it to resume execution at the next line of code. Let's run this code and see what we get. So this time, Excel does not blow up, but instead it gives us the wrong calculation. So this is one of the things you need to be careful of. As useful as resume next is, you need to be careful and mindful that it can lead to wrong results at the end of a calculation. Next, let's take a look at the onError goTo function. What onError goTo does, instead of resuming execution at the next line, it goes to a line that you specify. You specify the line by assigning a label. Let's take a look at how that works. Let's copy our code from before and use it in our onError goTo routine. So this time, instead of resuming next, what I want to do is onError, I want to go to a specific location. And this location can be anything you define. You can call it anything you like. Having defined your label, you need to put that label somewhere in your program, usually towards the end. You put the label in and then you put a colon at the end of it. And then anything you write after the label will be the code that's executed as soon as there's an error. So when there's an error in this line, execution jumps over whatever else is following that line and it goes and starts execution from your label. So onError, it goes to whatever your label happens to be. So now we can put a message box here. Let's put a breakpoint and let's run the code and see what we get. So as before, we're initializing our vial volume we're initializing our required dose, but we've forgotten to initialize our available concentration. So this will lead to a division by zero error, except we've told Excel where to go if there's an error. And Excel jumps over all other lines of code and goes and executes the program that follows your label. And this time we get a nice friendly error message. An error has occurred in the drug dose calculations. And this is our own message box, so we can style it and name it whatever we like. Now, there is one thing you need to be mindful of when you use the onError goto function, and that is what happens if there is no error. Let's comment out these lines and see what happens when we run the program. There's no code executing, so there will be no errors, and let's see what happens. And as you can see, we still get an error message saying an error has occurred in the drug dose calculations. Now, we know there have been no errors because we've commented out the code. So why is this? Whenever you use the onError goto, you have to realize that as program execution continues, it doesn't stop when it gets to that label. It continues onwards until it gets to the end sub. So just before your label, you should always say exit sub, so that Excel knows that if everything that's occurred up to that point is okay, it can exit at that point. It doesn't need to execute whatever is after your error message. So if we run that code again, this time there's no error. If we uncomment out the code and run it again, we get our nice error message. So you must remember, whenever you use the onError goto, remember to say exit sub before you get to the label. Next, let's take a look at the error object. The error object contains important information about our error. It contains the error number and it contains the error description. And we can use it to build nice error messages to pass on to our users. Let's take a look at an example. Let's copy our code from our error goto and paste it into our error object subroutine. Now this time, instead of passing a generic error message to our users, I want to pass on a specific error message. I want to give them the error code by concatenating on the error object's error number property. And I also want to give them the error description. So I'll concatenate on the error object's description property. So as before, I am not setting my available concentration, so that will be 0. I'll get division by 0 error, and because I have got my goto function set up, Excel will jump to my label and display a message to the user. Let's run the code and see what we get. So now I have a specific error message. Error code 11, division by 0. Finally, let's take a look at how we can write complete error handling for a subroutine. Here's the scenario. We've been asked to write a program to import a file that contains drug prescriptions for our patients. We want to open that file, import the data into our prescriptions tab, and then use that data to do some calculations. But we want to write this subroutine in such a way that any error that occurs is highlighted to the user. So let's see how we go about doing this. Okay, let's copy over some of our previous variables and reuse them here. On error, we want to go to drug dose error. And before we get there, we need to make sure we put our exit sub. And we want to copy our label and declare it there. So as we want to copy this data from a text file, let's declare some variables to hold our file number, our file name, and the next line. We'll set the file number equal to free file. And now we can set the file name by using the application object's default file path and concatenating on our file name. So we think we've got a file called dose prescription. And we think it's in the default file path. If you remember in Excel, your default file path you can get by going to Options, Save, and looking at your default file path. So we want to open a file called drug prescriptions in that location. We use the open method. And we open for input as, and we put our file number. With our file open, we can use our Sheets object and select the prescription tab. And then we can use a do until loop to loop through the file and write the values out to Excel. So let's declare a variable for our counter. We initialize I, and then we say do until we get to the end of the file. And as we loop through, we get each line. And we put it into our next line variable. And then we can use the range object and set its value property to the next line. And we remember to increment our variable. And down here, we can handle any errors. So let's run the code and see what we have so far. So we have an error number, error 53, file not found. So let's use a select case based on error code. So what I want to do is set a select case based on the error number. And then I want to say whenever error code is 53, I want you to run this error message. And I want you to resume at a line called file not found. For all other errors, we alert the user that an unanticipated error has occurred. And we remember to concatenate on the error number and the error description. And we put our end select. So when the error is error code 53, we display an error message and we resume at the file not found label. For all other errors, we alert the user that an unanticipated error has occurred and we give them the error number and description so they can take action accordingly. Now let's add in our error label. And the only thing we need to do after file not found is to close the file. Before we run the code, let's set a breakpoint there and let's run the code and see what we get. So we get to the point where we are about to open the file. The file is not found, and so we go into our drug dose error section. The error code is 53, so we display that message box, and we resume at the file not found label. We close the file and we exit the sub. Okay, next let's assume that as a backup to our file not being found, we have some data in our prescription tab that we can use. So we have some drug doses here. Let's see how we can calculate volume to administer using these drug doses and write error codes around that to handle anything that can go wrong. So let's set our vial volume. Let's use the sheet subject to switch over to our prescription sheet. And let's declare some variables for our patients. We assign patient 1 dose using the range object. And patient 2 also using the range object. So for patient 1, the volume to administer will be equal to patient 1 dose divided by available concentration all multiplied by the vial volume. And let's use a message box to display the volume to administer for patient 1. Okay, so we're calculating the volume to administer using the patient 1 dose, the available concentration, and the vial volume. Notice that we haven't yet set the available concentration, so we will get a divide by 0 error. Let's see how our error handling code handles that. So the first error is the file not found error. And then we get an unanticipated error, error code 11, division by 0. So if you know the error codes that are likely to happen, you can add another case. And you can put a custom error message there. You forgot to set available concentration. Okay, let's run that again and see what we get. Error code 53, file not found. And then you forgot to set available concentration, division by 0. And so you begin to see how, if you know the types of errors that can occur in your program, you can set specific messages for different types of errors and guide the user as to what they need to do to be able to execute the program successfully. And if all else fails, you can have some way of alerting the user that something's happened that you hadn't anticipated, but you can tell them the error number and the error description so they can take appropriate action. So in this module, we have looked at a number of types of errors that can occur, everything from compilation errors to missing files to simple mathematics errors. And we've seen various ways to resume our programming depending on the type of errors that occur. We can resume at the next line if it's an error that we think we can progress with the application for, or we can go to a specific line where we can handle what's gone wrong. We can use the error object to get more information about the error, which we can pass on to the user so they can take appropriate action. And we have taken a look at how to write a comprehensive error handling routine to anticipate all types of errors that could go wrong. So now you are ready to write complex programs and anticipate all sorts of errors that could go wrong and gracefully handle those for the user. I hope you enjoyed this video, and I'll see you in the next video.